All right, today we are diving into something that is so fundamental. It's basically the alphabet of our digital world. It's the simple, kind of elegant structure that lets your phone find one single contact in a list of thousands, like instantly. So how on earth does that work?
I mean, really think about that for a second. You type maybe 2 or 3 letters, and bam, there's the name you're looking for, out of hundreds, maybe thousands of contacts. It seriously feels like magic, right? But it's not. It's just a really fast and organized system. The question is, how does the computer actually pull it off?
You know, when you boil it all down, this is what computers do all day, every day. They look for stuff. Whether it's finding a file, pulling up a song in a playlist, or finding a friend on social media, it's all about sifting through this giant digital haystack to find one specific needle. And without a good system, that would be impossibly slow.
So how do programmers solve this? Well, they start by creating a really neat, orderly little street for all that data to live on. In the world of computer science, we call this street a one-dimensional array. It's such a simple idea, but it's got an incredible amount of power.
Okay, so here's the textbook definition. Let's break that down into plain English. All of the same type just means you can't make, say, numbers and words in the same list. It's got to be all words or all numbers. And continuous sequence? Now that's the magic part. It means every single item is stored right next to its neighbor in the computer's memory. There are no gaps, and that is what makes them so lightning fast to get around in.
To make this super clear, let's just run with that street idea. I want you to picture your data living in a row of houses. Each house holds one specific piece of info, and just like a real street, they're all lined up perfectly, one right after the other.
And here's our street. We've got 5 houses, and each one has a specific fruit inside. You can see apple is in the first house, banana is in the second, and so on. It's just a simple, clean, organized list. Super easy to picture, right? But of course, what good is a street of houses if you don't know where anything is? It'd be total chaos. To bring order to all of this, every single house needs one crucial thing: an address. Computers need that exact same system to find any piece of data.
Now, this right here is one of the most important and sometimes weirdest rules in all of programming. The computer's address system, which is called an index, starts counting from 0. So the first house is at address 0, the second one is at address 1, and our fifth house, Fig, is actually at address 4. It feels a little strange at first, I know, but you get used to it. That zero-based counting is absolutely fundamental.
Okay, so our data now has a home, and it has an address. We have a perfectly organized street. So how do we actually find what we're looking for? Well, we use the most straightforward method you can possibly imagine. We just start at the beginning and go door to door.
Let's give ourselves a little mission. We need to find the house that's holding the word cherry. We don't know its address, so we're just going to have to go looking for it. How would a computer do this in a logical way?
This is what we call a linear search. It's incredibly simple. The computer goes to the very first address, address 0, and it asks, is Cherry in here? Nope. Okay, on to the next one. It moves to address 1. Is it here? Still no. Then it gets to address 2, checks inside, and bingo, it found Cherry. Now, here's the crucial part. As soon as it finds it, it stops. Mission accomplished. It doesn't need to check the rest of the street.
Now, I know what you might be thinking. This whole door-to-door thing seems, well, a little basic. And you're right, it is. But that simplicity is actually its greatest strength. For lists that aren't gigantic, it's super efficient and it's totally reliable. This whole process, the linear search, is one of the very first things every programmer learns because it's the logical foundation for pretty much every other search method out there.
So why did we just walk through all of that? Why did we go down this little digital street? Because this simple concept, the array, is quietly running your entire digital life. Seriously, this isn't some obscure theory. It is absolutely everywhere. That music playlist you listen to every day? It's an array of songs. Your to-do list? That's an array of tasks. A leaderboard in a video game is an array of scores. And the contacts in your phone are an array of, well, contacts. Once you see it, you start to see it everywhere. These simple ordered lists are literally the skeleton holding so much of our software together.
And that really is the big takeaway here. This humble, one-dimensional list is an absolute titan in the world of programming. Its ability to store data in an ordered, easily accessible way is what allows for the speed and the organization that we just expect from all of our devices.
So, Going door to door works great for a single street. But what happens when you have millions or even billions of houses? Searching one by one would take forever. That's when programmers need much smarter, much faster ways to search that entire digital city. But that, well, that's a topic for another explainer.